Greetings. This is the NOAA Ecosystem-Based Fisheries Management Seminar Series. It's a monthly series offered on the second Wednesday of each month. This is Peg Brady, based here in Silver Spring, Maryland. Today we are happy to have Siddon from our NOAA Fisheries Alaska Science Center based in Juneau, presenting remotely from Juneau. She has co-authored this presentation with her colleagues Stephani Zador and Dorn, both from the Alaska Fisheries Science Center. And the title of today's presentation is Communication, Collaboration, and Transparency, Tailoring Ecosystem Science to Inform Fisheries Management. We'll allow Yvette to do the presentation, and then obviously if there are any questions, folks on the line and here in the room, we can take those questions after her presentation. Folks can use the chat online and send us questions, and we will take those up at the end. And just a quick reminder, our next presentation is on July 10th, same time, and that will be Morgan Kilgore, currently with the Delta Stewardship Council Science Program, and formerly with the Gulf Fisheries Council, and she will be presenting on question of why is ecosystem management so hard. So stay tuned for that on July 10th, and we look forward to having Morgan join us remotely from California. So again, thanks Yvette, and to your colleagues Stephani and Martin. Appreciate your efforts in today's presentation. We look forward to it. So I will turn that over now to you, Yvette.
Okay, great. Thank you, Peg. Can you hear me?
Yes, you're coming in nicely.
Okay, great. Well, first I want to thank you for the opportunity to present today on the work we're doing in Alaska around ecosystem-based fisheries management. It's a pretty exciting and dynamic and changing time in Alaska's ecosystems, and I think also in the processes and the products we're developing around EBFM. So it's a great time to talk to you. I want to thank Stephani and Martin as well. The sort of evolution of EBFM here in Alaska has really been a collective team effort, and this seminar reflects some of those different products and builds on a lot of people's contributions to sort of the greater whole of what we're doing here at the Alaska Fisheries Science Center. So there's a variety of ways that we practice ecosystem-based fisheries management in Alaska, and I've listed a couple of them here on the slide. Things like optimum yield caps, like the 2 million metric ton cap on groundfish fisheries removals in the eastern Bering Sea. On the left-hand side there, the climate-informed ecosystem models and management strategy evaluations like ACLIME is addressing. Gear modifications like streamer lines, and then fishery closures and protected species catch limits as well. And then the one I'll focus on today is our ecosystem status reports, and I think many of you are familiar now with the ecosystem status reports, but just a few highlights for how we use them in Alaska and how we think of the sort of key ingredients that make them successful in the uptake of ecosystem information into the management process. The first, they're listed, well actually the second on the right there, that they really are tailored to our North Pacific Fisheries Management Council. And then second, that they are closely linked with the annual stock assessment cycle, that in the annual cycle of stock assessments, we're annually producing these ecosystem status reports. So they're really linked together in the process. A quick history of the reports. We've been doing these for a while now. These have been produced annually since 1995, but not in a static form. These have been evolving. They were originally produced in a single report, a compendium of all information from the eastern Bering Sea, Aleutian Islands, and Gulf of Alaska, and then a general discussion within that one report on ecosystem-based management. Over time now, what we produce currently are report cards, ecosystem assessments, and indicators broken into reports by each large marine ecosystem. So we have an eastern Bering Sea report, Gulf of Alaska, Aleutian Islands, and in most cases, even within those large marine ecosystems, the reports are divided by subregions, like the eastern Gulf of Alaska versus the western Gulf of Alaska, reflecting the really dynamic nature of those different ecosystems. And they're also adaptive, and so we revise them annually, both in response to feedback we get through our council process from the Scientific and Statistical Committee, and then also based on new information that becomes available from scientists working in any of those regions. And we have new indicators that come into the report every year, and we indicate that on the title page or table of contents page. The goals are, again, very tailored to our primary stakeholder, the North Pacific Fisheries Management Council. So each report provides an annual synthesis of the ecosystem status. We receive anywhere from 40 to 60 individual indicators into the reports, and then we synthesize all of that information, making links across indicators into a salient story of what's happening in the ecosystem for that year. And that provides the context for the ecosystem approach to fisheries or ecosystem-based fisheries management. Another sort of logistical ingredient that makes for this successful uptake of ecosystem information is that we literally present these ecosystem syntheses first to the SSC, our Scientific and Statistical Committee, and to our council, providing that ecosystem context before they hear the individual stock recommendations. And that can inform qualitatively the ecosystem, the discussion, that then can have a quantitative impact on quota setting. So you would think, having done this every year since 1995, we'd have it pretty well figured out, but things are changing, and they change every year. But this general flow of how we inform the council process is shown on the slide. We produce our ecosystem status reports annually and in parallel with the stock assessments, and that happens for both sides, under fairly compressed time frames in August and September, drawing on survey information from the current year. And then we present to the plan teams in September and again in November, and we had historically presented to the Scientific and Statistical Committee and the Council only in December, and I'll talk about how that has changed more recently. But times are changing, both in the ecosystem and in our process and the products that we're producing around ecosystem-based fisheries management. And so I'm going to talk about some ecosystem things that are changing and then some sort of tactical things we're doing that are new. So you may have heard of the blob, the marine heat wave that occurred in the Gulf of Alaska from 2014 through 2016. We also had an unprecedented lack of sea ice in the northern Bering Sea over the winter 2017 to 18. And then what we're affectionately calling the double whammy, this second winter of little to no sea ice, again in the northern Bering from 2018 to 19. And this sort of exemplifies why the ecosystem-based management process and the products need to be robust to changes in the ecosystem, as well as robust to our scientific understanding of how the ecosystems are responding. And so if we think about what we would consider successful examples of EBFM in Alaska, we've sort of thought of these three common themes: communication, collaboration, and transparency. And so the rest of the talk will be structured around these themes with some examples of each of them from recent related activities through the lens of our ecosystem status reports. So I'll start with communication. There is lots of communication, not only in this annual assessment cycle of presentations to the plan teams, Scientific and Statistical Committee, the Advisory Panel, which is a body of stakeholders and industry representatives, and the Council, but also throughout the year, we're talking both within programs and across divisions of the Alaska Fisheries Science Center, just lots of sort of one-off conversations, idea sharing, brainstorming about what folks are seeing in the ecosystem and what we think it might mean. And then more and more recently, we're receiving lots of stakeholder invitations to come and talk at industry meetings, at community meetings, at working groups, to come and talk to them about what we know about the ecosystem and how things are responding. And those stakeholder invitations have been really, I think, really a two-way conversation of what they're seeing and what we're seeing And this idea of it being sort of on their turf and being a really open line of communication for the information that we're gathering. So this next slide is just a graphic to show all the different lines of communication built into our process, and it's probably not even 100% complete. But you can see that data and information flow from lots of different sources into the ecosystem status reports and into the stock assessments. You'll see a purple box there in the stock assessment box labeled ESP. That's also a new developing product, the ecosystem and socioeconomic profiles, and I'll talk about that under the transparency section. And just to note, in this process, our scientific and statistical committee sets the final ABC, and then that information is passed to the council, who then sets the final TAC specifications. So there's multiple layers of review of the ecosystem status reports through our council process, and lots of opportunity for public input and comment to what we're seeing and reporting. And I just want to point out again the timeliness of matching the annual stock assessment cycle and the annual production of the ecosystem reports really facilitates the uptake of the information into the process. It's also very iterative, so every year we're revising and refining our reports to be useful to what the SSC and the council want from us in terms of ecosystem information. So this is just an example. Every year in our reports, we respond to the comments from the Scientific and Statistical Committee minutes from the previous December. So this is just an example. They're saying the SSC is pleased to see the addition of the rapid zooplankton assessments included for both the Bering Sea and Gulf ecosystem reports. As requested by the SSC, these data are shown with historical context. And so this is just an example where we get feedback from what the SSC or council would like to see, and then we incorporate that in the following year's report. And so our response there is in the regular font there, just saying, in fact, we actually continue to improve on those kinds of indicators in the report. And lastly, under communication, the other new product that we piloted last year were these in-briefs. And this is a 4-page, sort of glossy, public-friendly summary that accompanied the multi-100-page full ecosystem status report for the Bering Sea. And we really were targeting the broader council audience and broader stakeholders with this 4-page glossy in-brief. It documents all of the highlights, and also because it's finalized following, or at actually, the December council meeting, it also includes how the information was used in the quota setting process. So this next slide is showing the sort of inside spread of this 4-page brief. So on the left-hand side is just a really high-level summary, sort of big picture, what things did we really pull out as important in terms of how the ecosystem responded. Last year, the big story was that lack of sea ice in the northern Bering Sea. And so the subsequent stories really were different between how the northern Bering Sea responded and how the southeastern Bering Sea responded. The color coding on that left-hand side matches the icons in the graphic on the right, and the arrows just denoting whether indicators, abundances were up or down from recent past. And then on the back page of this 4-page brief, we have a future projection section of what we can expect to see, sort of biological information coming in the form of 9-month forecasts for the Bering Sea. And then this management uses section, which really is written in real time at that December council meeting for how the information was used in setting quotas for the upcoming season. The right-hand panel are hot topics, so things that were going on in the ecosystem that were really sort of note to community members or stakeholders for us to track of what's going on in the ecosystem as well. So next section, we'll talk about collaboration. The ecosystem status reports, as I said earlier, they're really an accumulation 40 to 60 individual contributions, pieces of data, time series on different aspects of the ecosystem. And the scientists and knowledge holders of both local knowledge and traditional knowledge, those contributions remain attributed to the individuals who provide that information. So all of the contributors' names are listed on the front page of all of the reports. That's that top left photo. And their names also appear within the report with their individual contribution. We also keep the contributors' names on any slide when we present that information in these presentations. And that really creates this sort of win-win for contributors who get credit for the management application of their science, and also to managers who then get a more comprehensive suite of information of what's happening in the ecosystem. Another example of collaboration that sort of popped up last year after following this really unprecedented lack of sea ice in the northern Bering Sea over the winter 2017 to 18, the Alaska Fisheries Science Center pulled together, well, I should back up, that lack of sea ice was a result of these three sort of perfect storm events. One was residual heat in the system that delayed the freeze up of the Chukchi and prevented ice from forming into January of 2018, which was much delayed. And second was this, in the middle there, this persistent, really high pressure system centered over the Gulf of Alaska that kept the Aleutian low pressure system, the purple sort of blob there, pushed northwest over Siberia. And that set up some wind patterns, excuse me, shown in the bottom there, where typically winds would come out of the north and push cold air and ice over the Bering Sea, but what we saw in February of 2018 were these anomalous winds that came from the south. They were warm and moist, and they pushed that ice back out of the northern Bering Sea and prevented it from freezing. So as a response to these really anomalous and unprecedented events, the Science Center convened 2 northern Bering Sea synthesis meetings, pulling together folks who had information on what impact that lack of sea ice was going to have on the ecosystem, pulled 2 meetings together with the idea of providing any early warning sort of red flags of ecosystem impacts to our council. And so we gathered scientists and other knowledge holders with these terms of reference for these meetings. They're shown in the right that you know, we were really relying on people giving us pretty hot off the boat new data that maybe they, you know, that we needed to guarantee that, you know, the application of this information was to inform the council, and that so no use or reproduction of the data without explicit permission of the contributor was really our main term of reference there. And so that synthesis informed later discussions about changing stock distributions, which then had direct impacts on setting the max allowable biological catch for 2019. And this is a quote here in the middle from the Scientific and Statistical Committee minutes from December of 2018, just saying kudos to the authors and collaborators for that August workshop to provide early warning on anomalous conditions in the northern Bering Sea. And so given the success of those meetings, which were at the time sort of ad hoc, we have now begun convening these data sharing meetings every year. And so just last week in Seattle, we convened the first spring peak meeting. PEAK stands for Preview of Ecosystem and Economic Conditions. This meeting was funded by the IEA program, and it really is a formalization of the process that we convened these meetings last year about the lack of sea ice. So the objectives were twofold. One, to review the hot topics from the 2018 assessment cycle, you know, sort of what do we know now that we didn't know then, and are we collecting the right kinds of data to address those topics? And then to identify any areas of concern or conditions that may be relevant to the upcoming stock assessment cycle. again, are we collecting the right data to track those over this upcoming field season? And with those identified red flags, should they persist, should we be presenting to the council in October with those early warning indicators? So that end goal, sort of twofold. One, to inform upcoming surveys. What are the red flags we think we're seeing now that we should track through the season? And then, should they persist, presenting those to the council as part of our broader EBFM mission. And so again, from the SSC minutes back in October of 17, this is the formal request for these October heads-up presentations. Sets of ecosystem data that indicate there may be problems not accounted for in the assessment models need to be brought to the attention of the SSC and plan teams as early in the process of setting specifications as possible. And so the request was to present them at the October council meeting, which we then did in October of 2018, following the lack of sea ice in the northern Bering Sea. So the last theme is this theme of transparency in our information and in our communications. So we really feel like this transparency is an essential component for building trust, and building trust is really essential in the process, especially when we're faced with these challenges. And by challenges, I mean ecosystem and stock changes, really rapid changes that can have ecological and economic implications. So the example here on the slide is the marine heat wave that occurred during 2014 to 2016 that had huge impacts on the ecosystem and led to the decline of Pacific cod. At the bottom in those blue boxes are just a few headlines that came out connecting the marine heat wave, affectionately termed the blob there, and the decline of Pacific cod. So on this next slide, just showing, this is sort of a one-slide summary of a lot of information and a lot of conversations that went into sorting out what happened to the Gulf of Alaska Pacific cod in 2017. So the stock assessment author is Steve Barbeau. This slide just summarizes what happened in that process. So they saw a 71% decline in the abundance from the bottom trawl survey biomass between their biennial surveys of 2015 and 2017. And as soon as Steve saw this decline in his model, to his credit, he really left no stone unturned in trying to piece together what might have happened to the stock. And so this included conversations with oceanographers and biologists and ecologists, anyone who had information pertinent to stock and the early life history or the ecology, try to figure out what had happened. He also had frequent and informal communication along the way with stakeholders, and that helped to sort of evaluate the consistency of what he was finding in the data and what they were experiencing on the fishing grounds. And so this early and sort of wide broadcast communication of these preliminary results through the council, through public comment, and the media allowed for everyone in the fishing industry and participants time to plan and adapt for what was upcoming going to be a pretty big reduction in the ABC for this stock. So there was lots, because of this communication and because what Steve was bringing to them from the scientific evidence side really matched with what fishermen and industry were seeing on the grounds, that led to a lot of buy-in and support. And again, building that trust and transparency between the two. And so a reduction for 2018 ABC was a reduction of 80%, which could have been, of course, much more contentious, but because this information was brought so early and really in a very open manner, and because it matched what fishermen were seeing, the process went much more smoothly. Another new process under development under this theme of transparency are risk tables. These were introduced in 2018, last year, for just a handful of stocks as a pilot program. The idea of the risk table was to document all concerns external to the stock assessment models that might be used to reduce ABC from max ABC. And this was a process that was happening very informally and ad hoc over the years. And the idea of the risk table was to capture all of those sort of informal ad hoc reasons or justifications in one table, and that really was to increase the transparency in the decision-making process. It does not represent a change to how decisions have been made historically. It just represents a change in how we communicate how those decisions are being made. The other thing it does for those of us sort of tracking how ecosystem information is used in the process is it allows us to document when ecosystem information is considered, but does not result in a reduction in quota. And capturing those sort of zeros in the process is important, and we've sort of been unable to track those so far in our process. So this slide shows the risk table. It categorizes information into the 4 columns. So the first is assessment-related considerations, things inside the model. The second are population dynamics considerations. The third are ecosystem considerations. And then the last column, the fishery performance considerations, that column was added after the SSC and Council reviewed the use of these risk tables last year. So I'll show some examples of risk tables from last year, and you'll see they just include the first 3 columns. But it's really important to point out there's no double counting of information. So if there's already a concern or a buffer that's accounted for in the stock assessment model, we don't double count for that in this table and then further reduce ABC. This is for things outside of the stock assessment model. So I'll show 2 examples. The first is for the 2018 Eastern Bering Sea pollock stock. So you can see the 3 columns: assessment-related, population dynamics, and environmental or ecosystem considerations. And just as a quick sort of summary under the assessment, the stock assessment author, Jimmy Anelli, notes that the model tracks the available data well. He assigned it a level 1, showing no increased concerns there. Under population dynamics, he notes that the recruitment is likely to be below average, and therefore he gives that population dynamics a level 2, substantially increased concerns. And then under the third column for ecosystems, the lack of sea ice in the northern Bering Sea resulted in decreased productivity to the system and insufficient prey resources. So that column was also assigned a level 2. And then functionally what happens is you look across all the 3 columns, and basically the overall score is your highest, whatever your highest level of concern is. So for this stock, the overall score was a level 2, substantially increased concerns. And the result of that was the author recommended an ABC of 70% of the max permissible. So that represents a 30% reduction based on a tier 3 calculation. But not all times when we consider ecosystem information does it result in a reduction. So this next example is from the 2018 Bering Sea Aleutian Islands Atka mackerel assessment. Same structure here. Under the assessment, the stock assessment author noted adequate fits to the data and gave that column a level 1, typical to moderately increased concerns. Population dynamics column notes that the stock trends are typical, and so that also was assigned a level 1. And in the ecosystem considerations column, they noted that foraging conditions have been stable, also a level 1. So the overall score being level 1, normal, no elevated concerns, the author's recommended ABC was 100% max permissible, set at max ABC. This is just a quote from the Council's December 2018 newsletter saying that the Council discussed the utility of the risk tables and concurred with the SSC to recommend the inclusion of these in every assessment, as time allows, to provide transparency on some concerns that cannot be addressed within the assessments themselves at this time. And so risk tables will be included for all stocks in our upcoming 2019 assessment cycle. So this next graphic sort of pulls together all of the different pieces being produced or used at the Alaska Fisheries Science Center in supporting ecosystem-based fisheries management, and shows how the information flows through risk tables, through ESPs, through ecosystem status reports into the council process. So the honeycomb on the right there, those other council processes, a lot of those refer to that very first slide I showed, things like optimum yield caps and gear modifications. Those are all sorts of other things that we do that address EBFM. And then moving to the left, the development of the ecosystem and socioeconomic profiles, those can be thought of as stock-specific ecosystem indicators and economic indicators. Those ESPs and with the ecosystem status reports feed this risk table, which are per stock and included in the stock assessments, and then that informs that annual harvest process and meets the council's ecosystem goals for EBFM. So I'll just spend a minute differentiating how ecosystem indicators might be used between our ecosystem status reports and these stock-specific ecosystem and socioeconomic profiles, because there could be some overlap in terms of specific indicators, but used for sort of a different utility between the two products. So the spatial scales of the ecosystem status reports, those are produced by our large marine ecosystems, and in some cases by ecoregion, Eastern and Western Gulf. We have Eastern, Central, and Western Aleutians. And the spatial scale of the ESPs, the ecosystem and socioeconomic profiles, those will be defined by the stock distribution. So as an example, sablefish is managed sort of Alaska-wide, so those indicators might be things that are Alaska-wide as well. The temporal scale of indicators that goes into the ecosystem status report, those are things that fluctuate on an annual cycle. So that, again, we're trying to inform that annual process of stock assessments. And so things that change and are responsive to annual shifts in the ecosystem can be really informative in that context. And the temporal scale of those more stock-specific ESP indicators could be mixed. It'll depend on being linked. Some may be linked to life history characteristics of a particular stock. And so they may be things that change on longer time scales. They may be things that change on annual cycles as well. The community scale for the ecosystem status reports will remain at sort of this aggregate community level of indicators, so mixed community pieces of information, and I'll show some examples on the next slide. And the scale, again, for the ecosystem and socioeconomic profiles will be species or stock specific. So these are just some examples of indicators that go into the ecosystem status report. So on the left-hand side, things that are large marine ecosystem scale. That map on the top is a map of the cold pool. It's something that's very familiar to folks working in Alaska, and it is one of the main sort of physical drivers of species distributions. And then we also have things on the ecoregion scale. So here's an example of temperature anomalies in the Aleutians based on Western, Central, and Eastern regions, subregions. In the center there, we're looking for things that are available and fluctuate on the annual time scale. So there's some examples of copepod abundances there. And then on the right, what I mean by aggregate indicators, we have an indicator, again, that's been in the report for a long time. It's really useful to look. It's a condition index based on length, weight, residuals. And while it's provided across, I'm just showing 4 here. I think in the full report we have 8 species that are provided. In the ecosystem status report context, we look at those things looking at whether all stocks are showing below average condition or all stocks are showing above average condition as really red flags across the ecosystem. And then the Oscars model there on the bottom, that indicates drift trajectories, wind surface based on surface winds, and that impacts a suite of winter spawning flatfish stocks. So that tells us about, in general, where larvae may have been advected to. If we take then some examples of stock-specific indicators, on the left there are things that would relate to Bering Sea pollock specifically. We have a couple of indicators that relate large copepod abundance to recruitment to age 3. On the bottom, looking at the energy density of age 0 fish in relation to recruitment to age 1. Those kinds of indicators are currently in the ecosystem status report, and as the Bering Sea pollock ecosystem and socioeconomic profile is developed, those indicators will move over to the ESP report because they're stock specific. In the center, there are a couple of indicators specific to Bering Sea Pacific cod, again showing that length, weight, condition metric. It can be used to look in aggregate at how fish are doing across the board, and then it can be pulled out specifically for Pacific cod to look at how that stock is doing over time in terms of condition. And then on the bottom, a relationship with a broader scale climate index of the North Pacific Index in relation to recruitment of Pacific cod. On the right-hand side, northern rock sole is one of those winter spawning flatfish that is impacted by whether that drift trajectory model transports the larvae to the inner domain. And on the bottom, an index that's under development in relation to northern rock sole recruitment is a combination of both the wind index on the bottom, were northern rock sole transported to the inner domain, that's suitable juvenile habitat, in concert with an index of the spatial extent of the cold pool. And the combination of those two things has high predictability for northern rock sole recruitment. So those kinds of indicators would go into these stock-specific ecosystem and socioeconomic profiles. So to wrap up here in terms of what we've learned, how we tailor information really requires an understanding of the management system and of user groups in terms of what information they need and want, and sort of how to make it digestible to them and on a time scale that is useful for them. Second is this flexibility or being really robust to changes in the ecosystem and changes in the way the council needs to get that information into the process. This quote is, I think, from the council, and we sort of keep it in the back of our minds when we're giving a lot of these presentations, is to inform but not to overwhelm, to think about who your audience is and how to tailor our information to be really understood by the whatever stakeholder group, and be able to have a conversation about whether it matches what they're seeing in their regions. And this idea that the communication, collaboration, and transparency are all there to build trust in the system, and trust in our process is really essential for effective uptake of ecosystem information into the management process. So just I want to acknowledge there's lots, of course, hundreds of people who contribute to our ecosystem status reports over the years, but also folks who contributed to some of the development of these new products are listed here. Clay Shotwell's really involved in the ecosystem and socioeconomic profiles. Karam has been very involved in our IEA program. Steve Barbeau contributed the Gulf of Alaska Pequod information, and Jimmy Anelli and Sandra Lowe were the authors of the risk table examples that I showed. And George Hunt and Peter Bovang, along with Stephani Zador, were really instrumental in the Northern Bering Sea synthesis workshops that have then led to this spring peak annual meeting. So I'll stop there. I'm happy to take any questions from folks on the line.
Thanks, Yvette. That was excellent. A great presentation. I'm going to turn to the audience here in Silver Spring. Any questions? Yes. Ellen Spooner. Maybe if you come up, Ellen, a little bit closer. That'd be great. Ellen is involved with the Integrated Ecosystem Assessment Program.
Yeah, hi, Yvette. Thank you so much. That was a really informative presentation. As Peg mentioned, my name is Ellen Spooner, and I'm the communications specialist for the IEA program. And something that I'm really interested in from your presentation is you mentioned you guys are capturing when ecosystem information is considered by the council, and specifically when it's qualitatively considered and maybe doesn't reflect in actual changes in the tag. Could you speak a little bit more about how you guys are capturing when that information is considered?
Yeah, definitely. Thanks for the question, Ellen. That's one of the main kind of arguments behind the risk tables, because up to this point, I think there have been lots of situations where an author or the SSC or the council may, in the back of their minds, be thinking about an ecosystem component and thinking about, how it may or may not impact a stock. And if ultimately no change or reduction to max ABC is called for, then in the minutes that, when we go to search ecosystem in minutes from the SSC or the council, that's not always captured. And so it's been really hard to track when it's considered but doesn't quantitatively impact ABCs. And so this risk table will be a way, in that third column, you'll see the ecosystem considerations, you'll see what the stock assessment author and working with the scientists and ecosystem folks, what they thought were maybe concerns, maybe potential red flags, and whether they thought that should lead to a level 2, a level 3, a level 4 categorization that then may have the quantitative impact on ABC. And so we saw it roll out in the handful of risk tables we produced last year. In some cases, it contributed to the reduction, the justification in the reduction in ABC. In other cases, it doesn't. And that's really sort of the hard and fast way that we can document those, what we call the zeros.
Okay, great. I think I saw a question online from, is it Shannon? Morton? I'm going to pull up the question here for you, Ellen.
Shannon wanted to know that you had some really great graphics and icons. You have a graphic designer working with you.
Yeah.
We do. We have been working really closely, especially this last year, with our graphics department and our communications department, which includes graphic artists. And so were really instrumental in producing the 4-page brief with those icons, and just in the kind of the broader thinking about how to make, a multi-100-page document more accessible to a broader audience. So we've been working really closely with our communications and graphics department.
And Yvette, are those 4-page fact sheets or in briefs, are they on your website? Can people look at those?
Yes, definitely. They are. I'd have to check, exactly what to Google to find them. But if you Google, we just produced it for the Eastern Bering Sea last year, but it's called the In Brief. It should be linked on our stock assessment page under our ecosystem status reports. It should link to both the full report and the In Brief.
And the In Brief. Great. Okay. Excellent. We have another question online from Ryan Morris.
Yes. He's asking, can you elaborate on the distinction between informative versus prospective advice to the councils and how that relates to management decisions in the context of EBFM?
Can you repeat that?
Yeah, it's a rather long question. He would like you to elaborate on the distinction between informative versus prescriptive advice to the councils and how that relates to management decisions in the context of EBFM.
Okay, well, I think I understand the question, and we talk a lot about that. The council recently adopted the Bering Sea Fishery Ecosystem Plan, and that in that process, there was lots of discussion about it being action informing, not sort of mandating responses at certain thresholds. And so I think our role is still to just inform the process as much as possible, to bring our sort of best practice understanding, if it includes mechanistic understanding for particular stocks or sort of aggregate indicators of ecosystem health, and to bring that information forward for them contextually to have in the back of their minds when they then hear the individual stock recommendations. Does that answer the question?
I hope so.
One thought is, Yvette, if you and Brian want to discuss this offline, we'll be able to provide you his email address.
Sure. Excellent.
If Brian wants to talk more about it. Any other questions online? Here? Yes, sir. Can you just say your name?
From the IU's office here in NOAA, and my question is about production of the ESR. I heard that probably in Alaska they are now doing it automated way, basically connecting data directly to the whatever the tables, maps, whatever needed for that report. Is that true?
So if I understood the question, it's how automated the production of the reports are?
Right.
And it's an interesting question, and I think it's something that a lot of people sort of conceptually think should be easy, and in practice, at least what we've found in our process specific to our ecosystem status reports is they really are built on trust between the editors of the report and all of the individual contributors, that right now we're really leaning on that trust and that individual communication between a contributor providing us their information and it being used in the report. So we have not sort of taken that next step to try to automate, because we really feel like a lot of the success in sort of globally in the process is this communication and this trust between all of the different people who contribute to the overall knowledge that goes into the report.
It's an interesting. Thank you very much. I brought up that question because there is a lot of data out there that probably within IU's community that may not be used, being used for this kind of report, and the technology for automation and for data management is there. We can, like, let's say for Alaska, there is Alaska Ocean Observing System, and how we can use that platform to be able to generate those maps on the fly and without reducing the time, reducing the bias, reducing a lot of things. And I hear you what you're saying is that connections between collaborators and people that make things more exciting than just automating the system.
Yeah.
So it's an interesting thing. Yeah, exactly.
Yvette, do you interact with the Alaska IU's program?
Yeah, and I should say what was it, 2016, we hosted the Ecosystem Status Report meeting in Silver Spring with all of the different centers, authors of these Ecosystem Status Reports. And one of the things that came out of that meeting was funding for a contractor who would do just that, I think, is to leverage data sets that are available, whether it's from satellites, things that are consistent across all of the NOAA regions that could be automated. And I envision it for some of those, things like sea surface temperature, chlorophyll, those kinds of satellite-derived indicators. It could automate a process to sort of downscale it, visualize it, produce it for all of the reports, so there would be consistency across all of the different centers' ecosystem status reports, even though they may be produced on different timescales or with different end users in mind. There would be some consistency across all of the reports. So that contractor is on board and is starting, just sort of in the research phase of reaching out to each of the centers. The other thing we spoke with that contractor about doing is taking our 4-page brief and making it a web-based interactive product, so that for the indicators that really were that sort of high level, how did the ecosystem respond this year, those would be interactive on a website where you could click and see, and then sort of see how indicators are moving over, shifting time frames or something. So those are products under development, I would say. And for Alaska, when we have these conversations, and we have met with AOs, there's lots of data out there. We really have to sort of keep in our minds for the status reports who our audience is and what our end goal is. And for us, for our status reports, it's to inform our council. And there are lots of other, I think that the idea of like developing other products that would reach other audiences is where a lot of those conversations can go as well for filling other niches across the center and across NOAA.
Excellent, thank you.
Thanks, Yvette. Do we have any?
I don't think we have any more questions
Thank you
online,
for your question.
and I don't see any other questions in the room, so thank you so much, Yvette.
All right, Yvette, I think we're done.
Thank you, guys.
And again, thank you to you, Stephanie and Martin, for an excellent presentation. Appreciate all the effort that you folks go to develop these. And thanks to the NOAA Library, again, for ever hosting these events. And also, just a reminder, July 10th, Morgan Kilgore will be speaking more about ecosystem management and communications. So look forward to all of you joining us. And if you ever have any comments, there's an opportunity online there where you sign in to provide us some guidance, ideas, suggestions for future presentations. We're always open to ideas. So thank you again for attending today.
Thanks, everyone.
Thank you.